Hello and welcome back, everyone. Today we're going to be continuing our discussion on enzymes and the questions you're going to see on the MCAT that pertain to enzymes. Last video, we discussed general enzyme mechanisms and how to identify the class of enzyme within an MCAT question within a timely manner. Today, we're going to be doing the same exact steps, but we have some metabolism thrown in just to spice it up and review more topics as we answer the question. All right, so let's get back to it. So the question is asking us, during glycolysis, phosphofructokinase converts fructose 6-phosphate, F6B, into fructose 1,6-bisphosphate, F16BP, as shown below. Aldolase then converts F16BP into glyceraldehyde 3-phosphate and dihydroxyacetone phosphate. All right, so that was a mouthful. That was a lot of information thrown at us, and we haven't even gotten to the question. We haven't even gotten to what it's asking us. So here's the actual question. Respectively, phosphofructokinase and aldolase are examples of blank. Again, we're identifying classes of enzymes. Now, to some of you, you've taken biochem, you've went through semesters of chemistry. This is like as easy as it gets, right? You know the glycolysis steps by heart. You look at this and you know the answer already. But we're gonna answer this question on the assumption that you have little to no knowledge on the full glycolytic pathway, just so we can cover all our steps and go through more so test-taking strategies than just like finding the right answer, because you can find the right answer within 10 seconds. All right, so down here, I have drawn some structures for us. So this right here, we've got your F6 phosphate, your fructose 6 phosphate. We have a generic enzyme that has a base. I chose an enzyme that has aspartic acid. Most textbooks state that aspartic acid is involved in the phosphofructokinase mechanism. Then we have ATP. Now that's what we have here. F6P, ATP, and then we get our product, which is our F16BP. So I'll just like go through a general mechanism for how this product is obtained, okay? So we have this enzyme here, which is going to act as a base. It's going to come in, extract the proton from this hydroxyl. The protons are going to go to the oxygen, and you're going to get an oxide. All right, so after our aspartic acid has deprotonated the hydroxyl group, we have a negative charge on the oxygen, which is now going to act as our nucleophile. And we're going to attack the gamma phosphate group, kicking the pi electrons to the oxygen. You get a trigonal bipyramidal intermediate, but we're going to skip this step and fast forward. Pi electrons are going to collapse after you form your intermediate, kicking this bond right here, and we're going to get the following product. All right, so after a few more proton transfers, we get our product here, which is F16BP. And then you can notice that our enzyme now has its lone pairs again. That means it was deprotonated, and it was deprotonated by the beta phosphate group of previously ATP, now ADP, when we broke the bond to get the gamma phosphate. So now we regenerated our enzyme. Products are going to diffuse out, and we look back at the question here. The second step involves aldolase. And what aldolase does then is this compound, F16BP, will actually split down right the middle, and you get your dihydroxyacetone phosphate on this side and your glyceraldehyde uh, on the left side. Now, the mechanism for aldolase is really involved, and if you guys want, you can leave a comment so we can have a video just involving the mechanism of aldolase. So, we have practically solved more than what the question is asking. So now we're 100% ready to answer the question. But before we actually answer the question, there's a really important point I want to get to here. Now, you notice here that this step right here, F6P to F16BP, has one forward arrow, meaning it's favorable in one direction. However, we look at the aldolase step and we have reversible arrows. What is that about? This is going to come back to your glycolysis knowledge. We know phosphofructokinase is step 3 in glycolysis. Now, step 3 is one of the crucial steps in glycolysis, and this is actually going to be your rate limiting step. And why is that? Because when you add a phosphate to F6P, when you get the F1 6BP, now you have a really polar charged molecule within the cell and it can't leave. So the fate for that molecule is going to be to go forward. Also, the delta G for this, most people say it's about negative 25.9 kilojoules per mole. And in the reverse reaction, that would be positive 25.9 kilojoules per mole. And that's really unreasonable for it to be reversible. That's why it's only favored in one direction. So that was just like a little side discussion. But now we can get to answering the question. Now, what sort of reaction did we do here? We took a phosphate group from ATP and added it to the F6B to make F16BP. So I would say we have transferred a group from one compound to another. That's a hint. For the second half of the equation, using aldolase, we split down the middle. We broke bonds to form two compounds. Now let's look at the answer choices. A, an isomerase and a hydrolase. It wasn't really an isomerase in the first step. I know it may look like it, but don't forget that you added a whole new group. So it's not, you didn't just simply rearrange, you added a group. Definitely not A. B, a transferase and a lyase. Now, I'm really liking the sound of this one because, as we said, in the first reaction, we transferred phosphate groups, and in the second reaction, we split them down the middle. And lyase, we know, breaks bonds, right? So we're going to get our question mark, a ligase, and an isomerase. We didn't ligate anything in this compound. And also, in the second half, it says an isomerase, and we have already determined that it's not an isomerase for either of them. So you can cross that one out, even if you didn't know what a ligase is. B, an oxidoreductase and a transferase. Ooh, now this one, I would say this is the one that's a distractor. But you have to know, for an oxidoreductase reaction or enzyme to have happened, we have to have oxidized and reduced something. And usually, not 100% of the time, you have NADHs, your FADH2 involved as cofactors. So if you don't see cofactors in the reaction, there's a really high chance that it's not an oxidation reduction. So we can mark D, and also we know that the second one is not a transferase. So the answer for this question, confidently, is going to be B. All right, thank you guys so much for watching, and we're going to see you in the next video.